So these are the notes for section 5.4. This is really kind of a continuation of solving systems that we did last quarter. So first of all, I need to remind you that solving a system of equation means finding the points of intersection. Now when we've done this before, we only found one solution because we were finding the intersection of two lines, and the only way two lines could intersect would possibly be in one point. However, now they're not going to be just lines. You can see from the pictures we might have parabolas and lines or circles, and you could have more than one point of intersection. So for example, on this picture there is one point of intersection, so there would be one ordered pair for the solution. But in this next one there are 2 points of intersection. Hey my, I need to let little Miss Burn in, okay? In the last example, there are 4 points of intersection. So most of the ones that we're going to do will have 2 points of intersection, but just telling you that because it's going to be a little different than what you're used to from last quarter. Okay. So if you look at this system, we're going to start using the substitution method. So just like we've done before, you'll notice the first equation is already solved for y. So I'm going to take all of this and substitute it in for y in the other equation. So I'm going to start rewriting this equation. I've got 2x minus, and now I'm going to be sure and put all of that in a parenthesis because I'm going to have to distribute that negative on my next step. So I'm putting everything in place of y, and then the rest of the equation is equals 2. So I distribute the negative. And then notice since there's an x squared term, I know that I'm going to have to set this equal to 0 so I can factor. So I'll combine my 2x and my x. Now first I have the negative x squared. Like I said, when I combine the 2x and the x, that's going to give me a plus 3x. And then that last term is the minus 6, but I'm going to go ahead at the same step here and move that 2 over, so I'm going to be subtracting 2. So really I'm going to have a plus 4, and now it's still set equal to 0. Now I know you've heard me say before, I really don't like to factor when I have a negative on my x squared term. So I'm going to multiply all the way through by -1, which is fine, right, as long as you do it all the way across. So if I multiply all the way through by -1, now I have something that I think I can factor pretty easily. Let's see, that would be x minus 4, x plus 1. Maybe you can tell that I'm not going to use 2 and 2 to multiply to be 4 because that wouldn't give me 3 in the middle. So from that I have two solutions, either x equals 4, or from the other parenthesis x equals -1. Okay, and what that means is I have one point of intersection that is 4 comma something, and have another point of intersection that is -1 comma something. And so remember, just like we've done when we use the substitution method, once I get one answer, I need to substitute that back in so I can find the other. So if I put a 4 in for x, I'm going to have 16 minus 4 minus 6. Let's see, I think that's going to come out to be 6. And if I put in -1 for x, -1 squared is 1 minus -1 minus 6. I think that's going to come out to be negative 4. So there are two solutions because there are 2 points of intersection. Okay, so let's try another one. Look at number 1. Again, this is like completely set up for me, right? It's already solved for y. So I'm going to put this x squared plus 3 in place of the y in the other equation. So I've got 3x minus, again, put it in parentheses because we're going to have to distribute that negative. I still have plus 1 equals 0. So if I distribute my negative, and just kind of simplify, so negative x squared plus 3x minus 2. And like I said last time, I don't like factoring with that negative out in front, so I'll multiply all the way across by negative 1, and that's just going to change the sign of all the terms. And so now I think this will factor. I need both signs to be negative so I can get that negative 3 in the middle. So x is either 2 or x is 1. And again, what that means is there are 2 points of intersection. One of them is 2 comma something. The other one is 1 comma something. And like we said before, in order to find the y value, I'm going to take this and I'm going to substitute back in where I started. So if I put it in 2, I'm going to have 2 squared plus 3 would be 7. And if I put in the 1, 1 squared plus 3 would be 4. So there are 2 points of intersection that represent our solution. I don't think we need to do all of these examples. Let me go over to number. What do I want to go to? Let's go to number 5. Okay, so it doesn't look any different when you first look at it because this is already solved for y, right? I can substitute it. Whoops, I want to put it in for y, right? Substitute it in for y in the other equation. All right, I'm losing all my stuff here. If I substitute in for y in the other equation, I'm going to have x squared plus, now in this case, if you want to put this in parentheses, you can, but it's not necessary because there's not a minus in front that I have to distribute. So if I combine my like terms, I'm going to have 2x squared minus 2x, and if you think about moving the 5 over, minus 4. Now, when we factor, remember, we always want to look for a common factor first. So I'm going to go ahead and take out a common factor of 2. So x squared minus x minus 2. I don't need that parenthesis there. Minus 2. And now, just leave that 2 out in front, and we can factor what's left using our trial and error method. And that's going to work, because that's going to give me the negative 1x in the middle. And so when I solve, remember, if there's a number out in front, that doesn't give me any solutions. So I just have x equals 2 from the first parenthesis, and x equals negative 1 from the second parenthesis. So I'm going to substitute back in so I can find my y values. If I put in 2, I'm going to have 2 squared minus 2 times 2 plus 1. I think that's going to be 1. And if I put in negative 1, I'm going to have negative 1 squared is positive 1. Let's see. Minus 2 times negative 1 plus 1. I think that's going to come out to be a total of 4. So I have 2 solutions, 2 ordered pairs that represent my solution. Okay, so that's all of the, well, that's, enough examples from the homework. There are a couple problems that are a little more involved in the homework, and I want to do an example of that. So let's do number 5 from the homework together. So in this case, the y, I should say y, there's no, either of the equation has not solved for one of the variables, so I can substitute. So let's be smart. I'm going to take the first equation. The smartest thing would be to solve for x, so I'll add y. So y plus 5. And so that means I'm going to substitute that into the other equation in place of x. So I've got y plus 5, and then that x is being squared. I still have the plus y squared equals 13. Okay, now I could take this y plus 5, off to the side, and I'll like kind of over here, this is just me doing scratch paper. I could do, what is y plus 5 times y plus 5, and I could do the FOIL. But remember, we had a shortcut for that. It comes out to be squaring the first. We double the product to get the middle term, and then we square the last. So that's just from squaring the y plus 5. I still have the plus y squared equals 13. And so again, if I combine like terms, I've got 2y squared. Why do I have, this should be a 10y, sorry about that, plus 10y. And then if I subtract the 13 from the 25, it's going to be a plus 12. And so like last time, notice there's a common factor of 2. So y squared plus 5y plus 6. And I think that'll factor y plus 3, y plus 2. So I have two values of y, negative 3, y equals negative 2. And keep in mind that this is the y, so I'm going to substitute back in to find my x value. So if I plug in a negative 2, the x value is 3, and that means the y value is negative 2. And remember, this order pair is going to give me something comma negative 3, right? Because the negative 3 is the y. So if I plug that in for y, I'm going to get 2. So I still have two solutions. Just kind of have a couple different things we had to do to get there. All right. So for the homework, we did the rest of the homework that's listed here. But you don't need to do these at the bottom of the page. Excuse me. Because we'll save those for next time. So just 1 through 6 for the homework.